Okay, today I will share with you some results, some older results and some newer results that we have on the impacts of recreational power boats on the population of northern map turtles in Ontario. And this is work that I've largely been doing with Gabriel Blouin-Emers at the University of Ottawa over the last few years. But we didn't conducted this work alone. Many people have helped in various ways along the way. And particularly Sophia, Jane Schlepper and Michel Leveillé both have conducted their thesis, undergraduate thesis, on the impact of boats on turtles. And so some of the data I'll be presenting today are the data that they've collected as part of their thesis. We also received funding from various agencies over the years and had excellent support from the Queen's University Biological Station, where we've been conducting this work. So I'll start very specifically by showing you a turtle. This is a turtle. Her name or code name is CGV, and she is a female northern map turtle. I marked that turtle in 2005, and at the time she was intact. She didn't have any injuries, and I recaptured her in 2019 this year, and she had this big gash on her left side. And I'm showing you this particular turtle because you can see where the pointer is. This is just shy of where the spine is. So this turtle almost got her spine severed by a boat and so would have died. And this is a quite old female, and particularly perhaps a particularly important female in our population. And so this turtle is CGV is one of about 1,400 map turtles that we have marked in Lake Oppinicon since 2003 as part of a demography study. And for those who don't know, Lake Oppinicon is a small lake, part of the Rideau Canal, and it's located about midway between Ottawa and Kingston along the Rideau Canal. And what I have here on the left is the range map of the northern map turtle. So you can see that it's about, the tip of the arrow is in the wrong spot, but it should be, we're still at the very northern edge of the range of the northern map turtle. Unfortunately, there are many turtles in Lake Oppinicon that have marks of injuries from powerboats. So two more examples here, but these are relatively fresh injuries. They haven't completely healed. And we see when we started studying these turtles in 2003, we're seeing a fair number of these injuries. So we started recording them, and we recorded them between 2003 and 2007. And in that time period, I think we examined around 800 turtles. And overall, it was 4% of all the turtles we looked at that had injuries or signs of injuries that were consistent with boat collisions or propeller collisions. There's a strong bias towards female, however, and so when we only looked at the females, it was 7% of the females that actually were bearing scars from boats. And then in the years after 2007, I didn't keep track of these injuries as well as I had previously, but I started doing it again in 2019. And in 2019, after a fairly good capture season, where we got about 240 turtles, I looked at my data at the end of the season and realized, whoa, it's 13% now. And so that's a 6% jump in injuries between 2007 and 2019. So that suggests that perhaps this is a problem that is on the rise. And I'm looking forward to other years to see if it is indeed increasing in abundance. Hopefully it's not, but it sure seems like it might be. One of the big problem we have when we just look at injuries is that the only thing we know is the number of turtles that get hit by a boat and survive. So when a turtle gets hit by a boat, really two things can happen. It can survive, and it probably will have some kind of scar that we can detect and then measure it, or it will die. And we don't know how many turtles die. We don't in all, since 2003, I have recovered only a single turtle that I could say for sure was killed by a boat. And so do we not find them because few of them actually die, or because just they sink or something else happened to them, they get picked up by scavengers? So we don't know how many map turtles get killed by boat. And this is a big problem because that really limits our ability to determine the impact of boats on turtles. So without this sorts of data, we did the next best thing we could think of, which is basically throw math at the problem and simulate turtles using real data. So basically we did a population viability analysis to figure out, well, how much mortality is too much mortality. And so we use mostly demographic data from our own population, but we needed to we did had some blank, and so we borrowed some values from the literature, but by and large was all the demographic parameters were obtained from Lake Oppinicon. And we simulated the probability of extinction of our population in Lake Oppinicon, which is on the y-axis, versus the percentage of females that get killed when hit by a boat. What the simulation shows, if everything is valid, is that at about 10% of the turtles that get hit that die, then you start having a pretty high probability of extinction, and by 15% you're pretty much guaranteed you lost your population. So this is quite concerning, not very surprising. I mean, we know if you know a thing or two about turtles, you know that more or less any turtle population will be very sensitive to adult mortality. So not surprising. The big issue here is that we don't know where we are along that curve, because we don't know how many turtles get killed. And so I'd be really curious to hear if anybody has some suggestions about how you can actually get a good grasp on these numbers. So that was the part on the injury. Now let's move to the part on insults. So by insults, I essentially mean disturbances. So turtles love to bask, especially map turtles. They can spend their entire day basking, especially in the early spring. And basking, we know, is extremely important, at least for thermoregulation, but may also play other functions that we don't know yet, such as social bonding, for instance. And we also know that boats disturb basking turtles, so we were interested in finding out finding out more about the response of turtles to boat disturbances and the potential thermoregulation impacts of such disturbances. So we started doing some pretty simple, gathering some simple observation. We put cameras at basking sites, time-lapse cameras that are taking pictures every minute. And we did that in 2014 and 2018. We also in 2014 numbered a bunch of turtles so we could have individual response to disturbances from the cameras. We also experimentally disturbed some turtles. We basically approached the basking site with a boat. We flushed all the turtles from the basking site, turned around, and let the camera record the disturbances. And we did that because we wanted to have disturbances that we knew for sure were caused by a boat, because the way the cameras are set up didn't really allow us to determine what appears to be a disturbance. So by doing the disturbances ourselves, we have a tight control on the cause and timing of the disturbance. So using the data from 2014, we were able to estimate the number of disturbances that map turtle experience every day in Lake Oppinicon on average. And the way we estimated that is that whenever more than 50% of a turtle aggregation enter the water in a 1-minute interval, so essentially when you look at the picture, if at 12:49 you have 10 turtles, and at 12:50 you have less than 5 turtles, then we call that a disturbance. And as I said, we don't really know the cause of these disturbances. Probably most of them are caused by boat, but some presumably are also caused by predators or canoes or kayaks. And we're able to get nearly 120 of these such of occurrence, and then from that we estimated that map turtles get disturbed between once a day to about one time per hour later in the season when you have a lot of boat traffic. With the turtles that were numbered from 2014, we were also able to determine how long turtles take to return to bask when they get disturbed, and then we compare that to the time it takes for turtle to return basking when they don't get disturbed. So essentially turtles that just enter the water on their own volition and then come out sometime later. We're able to do that for a fairly large number of observations and calculate the average time it takes for turtles to resume basking at a particular site after a disturbance, and the average is 26 minutes. And then we also did that for turtles that enter the water on their own evolution, and the average for them to resume basking is 14 minutes. So basically, about on average, turtles that get disturbed spend about twice as much time underwater than turtles that don't get disturbed. So that really begs the question, well, what are the thermal consequences of these disturbances? If they spend more time in the water, they don't spend as much time basking, so they're probably experiencing cooler temperature, but what would be the overall effect of that? Well, the one way to do that would be to measure directly their body temperature. We didn't do that. What we did instead is that we measured the cooling and eating rate of actual map turtles from our population. So we look how fast they cool down in the water at different temperature and how quick they warm up outside of the water at different temperature, and use these rate of heating and cooling to simulate the thermal cost of a disturbance, and we plotted that thermal cost against the various numbers of disturbances per hour. So thermal cost is simply the difference between a turtle that doesn't get disturbed and a turtle that gets disturbed. The body temperature of a turtle doesn't get disturbed, and the body temperature of a turtle gets disturbed under the exact same environmental conditions, water and air temperature. So for instance, thermal cost of 3 degrees would be a turtles that get disturbed would be 3 degrees cooler on an average day than a turtles that didn't get disturbed. So what we found is that, not surprisingly, the thermal cost is much higher early in the season. That's because the water temperature is cooler and the air temperature is also cooler. When the water and the air is warm in July and August, then the thermal cost is pretty negligible. However, in May, particularly in early May, the thermal cost can be quite high. So rates of disturbances of 3 to 5 disturbances per hour can cool down the turtles to almost 4 degrees. So that's fairly high. In Lake Oppenicon in May, the disturbance rates are really low. It's about once a day. So we're in that bottom left corner of the graph, so probably nothing too concerning here, but it just shows that if you have high rates of disturbances, you can have turtles that are much cooler than what they're probably trying to achieve. Another consequence of disturbances is basking site use. So we know turtles bask a lot. We know, although the process behind is not well understood, they seem to not select basking site at random. So there's something about certain basking site that makes them special to these turtles, whether it's the thermal regime they experience. There might be social factors that are driving the selection of these basking sites, but clearly they're not basking at random, and they go back to the same sites over and over. So I was interested in figuring out, when they get disturbed from these seemingly preferred sites, what happened. Do they go back to these sites, or do they go somewhere else, or just don't go back basking? So in 2018, with Michel Leveillé, we disturbed some turtles from 4 different sites that have been heavily used by turtles over the few years we've been studying them, since 2003. And we perform at these 4 sites 17 experimental disturbances, and we only perform a single disturbance a day. And so we approached the boat, and there was a bunch of turtles basking, and then we made sure all the turtles were gone, turned the boat around, and then let the camera record the turtles returning to the sites. So what we have on this graph is the percentage of turtles remaining at a basking site after a disturbance as a function of the time since the disturbance. The negative values are times before the disturbance. So turtles, lots of turtles, 100% of turtles before a disturbance, then it goes down to 0 because we made sure they were all gone, and then we leave and the turtles come back. But we found that on average across the board, about 24%, the average about is 24% of the turtles do return to bask after a disturbance. We don't know the remaining. Do they go somewhere else? Do they not resume basking at all? But what is clear is that a single disturbance events per day affect the use of these habitat quite deeply. And that might have important consequences if these sites are important, if they're better quality for basking than other sites, or if they have some importance from a social point of view. So I mentioned that in Lake Oppinicon, we don't think the boats are having a huge impact, although the injury rates is on the rise. But if we look at the literature on the injury rates on turtles in freshwater ecosystems, we find that there's actually many populations that have much higher rates of injuries in our populations that are presumably much more impacted by boats, including population of northern map turtle in Trans Severn, studied by Jackie Litzgus and Amanda Bennett. And so if we take these values as some sort of an index of boat pressure, we see that there's a lot of populations out there that seems to be experiencing fairly high pressure. And there's a lot of boats in Canada. We actually have data on boats ownership in Canada from the National Marine Manufacturer Association, and they estimated that there's about 8.6 million recreational boats in Canada. Most of those are power boats. About 75% of them are power boats, and the remaining, most of the remaining boats are personal watercraft, so jet skis and those kinds of things. So there's lots of ecosystems that are aquatic ecosystems that might experience fairly high pressure from boats. So I want to finish this talk by putting out there a couple questions that I think would be important to answer in order to better understand the impacts of boats on turtles. The first one is trying to figure out, do turtles actually acclimate to boat traffic? So Peter Lindemann actually suggested that his population that he studies in Lake Erie of northern map turtles are relatively insensitive to boats. So in the sense that he repeatedly observed boat approaching basking turtles quite closely without causing any signs of disturbance, suggesting that perhaps they are well acclimated to boat disturbances and they don't perceive them as a threat. So, if it is indeed the case, it could be good from a thermoregulation point of view. However, there's another study published in 2013 on diamondback terrapin, in which they subjected terrapins to underwater boat noise, and what they found is that turtles, although they can hear the boat from the noise, they don't respond to them. They don't change their swimming patterns when confronted to a boat noise. They think it's because they have become acclimated to boat noise and they just basically ignore those noise. But they also think that the fact that they ignore the boat noise is the reasons why they get hit by boats so frequently. So acclimation, if it does occur, might be a little bit of a double-edged sword here, because it might prevent disturbance when basking, but might lead to higher collisions with boats. The other questions that I think should be that we have enough data now to start looking into is looking at whether education can actually be an effective way of reducing the impacts of powerboats. The NMMA has data on the activities boaters do when they're on their boat, and many of them use their boats for fishing, observing nature, or sightseeing. So presumably there's a fair number of boat users that might be open to change their behaviors around turtles in ways that might reduce impact. So I think there's some interesting studies to be done here where we could assess the perceptions of boaters to turtles and whether or not they're interested in adopting behaviors that could potentially reduce impact. And I will leave you on this for this talk. Thank you.